Yeah, seriously, Farid. In some of few more minutes, we'll be writing our finals.
Oh my god, I haven't studied yet about multithreading. I'm dead. Have you studied about multithreading?
Yeah, of course.
Can you teach me what is multithreading and so on?
Oh, yeah, of course, Farid. Anything for you.
Oh, thank you.
What is thread?
Okay, before we learn what is multi-thread programming, we should know what is the meaning of thread. A thread is nothing but a lightweight process, and it is the basic unit of CPU execution. So what is a process? A process is a program that is going to be executed in the memory. In each process, there will be threads. The uses of each thread is to execute different tasks in order to execute the program.
Shivam, I wonder what is multi-threading? It's just like a thread and has two threads. So what is multi-threading?
Okay, now let me teach you what is multi-thread. Most modern applications are multi-threads. Threads run within the application. Multiple tasks with the application can be implemented by separate threads, which are update display, fetch data, spell checking, answer network request. These are the examples. And process creation is a heavyweight, while thread creation is a lightweight. And it can simplify the code and increase the efficiency. Other than that, kernel are general multi-threads. Okay, now let me teach you about multi-thread server architecture. Okay, multi-thread server architecture contains three main components, which are client, server, and threads. The client will send request to the server, and the server will create a new thread service request to the thread, and at the same time the server will remove listening for additional client requests.
Oh, I see. By the way, Shivam. Oh, sorry for interrupting. It's okay. Come on. Join us. What is discussing about?
So right now we are discussing about multi-threading in operating system.
What did you guys have discussed so far?
Right now we are going to discuss about benefit of multi-threading. As you can see here.
The benefits of multi-threading. The first is responsiveness. Multi-thread may allow continued execution if part of process is blocked, especially important for user interface. Second is resource sharing. Threads share resource of process easier than shared memory or message passing. The third is economy. Cheaper than process creation, thread switching lower overhead than content switching. And lastly is scalability. A process can take advantage of multiprocessor architectures.
Oh, I see.
So that's all the benefit of multi-threading.
Oh, but can someone explain to me how it works?
Oh, I know how the multithreading works.
Okay, I will explain how multithreading works. A thread goes through various stages in its life cycle. For example, A thread is born, started, runs, and then dies. The following diagram shows the complete life cycle of a thread. Following are the stages of the life cycle. New. A new thread begins its life cycle in the new state. It remains in this state until the program starts the thread. It is also referred to as a born thread. Runnable. After a newly born thread is started, the thread becomes runnable. A thread in this state is considered to be executing its task. Waiting. Sometimes a thread transitions to the waiting state while the thread waits for another thread to perform a task. A thread transitions back to the runnable state only when another thread signals the waiting thread to continue executing. Time waiting. A runnable thread can enter the time waiting step for a specified interval of time. A thread in this state transitions back to the runnable state when that time interval expires or when the event it is waiting for occurs. Terminated. Dead. A runnable thread enters the terminated state when it completes its task or otherwise terminates.
Did you guys understand what I'm saying just now?
Yes, of course. Very, very understood.
But still, can someone explain me what's the difference between user thread and kernel thread?
Oh, I can help you with that.
User thread management done by user level threads library. There are three primary threads library: POSIX thread, Win32 thread, Java thread. Kernel thread supported by the kernel. Example of the kernel thread: virtually all general purpose operating system including Windows, Solaris, Linux, True64 Unix, Mac OS X.
But I'm still not sure with how many and what are the multi-threading models. Can someone explain?
Yeah, I can explain it to you, Farid. Multi-threading models. There are mainly three models, which are many-to-one, one-to-one, many-to-many. Let me explain you one by one. Many-to-one. Many user level thread mapped to single kernel thread is many-to-one, and the next are one-to-one. Each user level thread maps to kernel thread is one-to-one model. And the third is many-to-many model that allows many user level threads mapped to many kernel threads. In addition, there are two-level model thread which are similar to many model, except that it allows a user thread to be bound to kernel thread.
Are there any issues regarding about the multi-threading?
So, about the issue, there are so many issues regarding multi-threading, but I know some of it, so I will explain to all of you.
Alright.
There are some threading issues, but then I will explain only two of threading issues. First is semantic of fork class and exec class system call. Semantic of fork class and exec class. Does fork class duplicate only the calling thread or all the threads? So, some Unixes have two versions of forks. Exec class usually works as normal and replace the running process including all threads. The second is scheduler activation. Both many-to-many and two-level models require communication to maintain the appropriate number of kernel threads allocated to the application. Typically, use an intermediate data structure between user and kernel threads, which is lightweight process. It appears to be a virtual processor on which process can schedule user thread to run. Each lightweight process attached to the kernel thread. How many lightweight process to create? That is the problem, the issue. So, scheduler activation provide upcalls, which a communication mechanism from the kernel to the upcall handler in the thread library. This communication allows an application to maintain the correct number of kernel threads.
Is everyone clear with it?
Yeah, clear.
Very clear.
Good.
Crystal clear.
But
It's already time's up, so everyone understand what is everyone understand with multi-thread programming?
yes, for sure, yes.
Oh yeah. It's already time's up, so let's go for the exam.
Let's go.